Hi everyone, so this video is basically illustrate how to run the simulation of McCabe Thiele method by using the MATLAB code. I believe all of you have gone through the class for this chapter, so it will be easy for you to understand. I chose the example in separation textbook, which is example 11.41 at page 713. From this question, you know that the feed is 100 kmol per hour with 45 mole percent of benzene. The distillate containing 95 mole percent of benzene, and the bottom is 10 mole percent of benzene. The reflux ratio is 4. So we come to the MATLAB code, we run. So what is the mixture? In this case, it's benzene toluene, so we choose 1. Enter. XF 0.45, XT 0.95, XW 0.1, F 100. So come to the reflux ratio. You're given choice for you to choose. The first one is manual key in R, and the second one is R in terms of R min. So in this case, we choose the manual key in R, which is 4. So the first choice. So R is equal to 4. Enter. Liquid fraction is 1.195. You can see from the textbook. Enter, and you will run the code. So it takes a few seconds to run it. So the output is distillate flow rate, bottom flow rate, number of theoretical stages, and also a graph for you to determine the feed location. So just wait for a few seconds. It will iterate until 1.0. While waiting for this, I need to highlight some of the important things that to take note. Like for when you run this code, you will ask what is the mixture. So if let's say the component that you need is not given in this choice, you need to manual key in the equilibrium data by yourself. You can choose 4. Then you will come up. Please enter the liquid fraction X for the more volatile component. So you need to key in this way. Square bracket, then key in for the X value. Then enter, will come out this for Y, then you key in again. So in this case, you need to make sure that the number of data that you key in is same for X and Y. If not, it will come out with the error. X and Y must be the same error. Okay, so we get the result here. This is a graph. As you can see from here, you can determine the feed location 1, 2, 3, 4, 5. So you're not sure this one is 4 or 5. You can just zoom in. You can see at the 5 here. So the feed location is at the 5. So this is about the graph. So the output you get is distillate flow rate, bottom flow rate, and also the number of stages. So this number of stages refer to the number of theoretical trays plus a reboiler. So if you need the number of trays, you need to minus 1. So this is basically the all of the thing is for this simulator. Come back to the thing that I mentioned just now. So just to remind again, this X and Y, the number must be the same. Number of data you key in, I mean. So if not, it will come up with an error. X and Y must be the same length. So it will break and end. You terminate the simulator, and you need to redo again. So basically, these are the things that you need to take note only for this mass balance part. I think that the syllabus is not covered on the enthalpy calculation for the distillation column, which is reboiler and condenser duty, but I just wish to introduce some of the coding for the heat duty calculations. I'm not going to illustrate the example, but just to highlight some of the things that need to take note. Same thing, the upper part is the input for the mass balance of theoretical stage calculations, and after this Q, just now after Q you enter the iteration, the coding will run. But this one you will come up with the input for the calculation of condenser and reboiler duty, which quite a lot of things that you need to key in. So the things that you need to take note is the boiling point of the more volatile component must be lower compared to the less volatile component. Means that TA must be smaller than TB. So if your TBN is greater than TBB, it will come up with this error and terminate your code. And one more thing to highlight here is the saturation temperature of the distillate liquid mass fraction. So for the S small d must be smaller than S capital D. So if it is greater than, it will also pop up with the error box and also will terminate in N. So if you want to run this coding for the enthalpy calculation, you can refer to question example 11.62 at page 737. All the data are given, and what you need to do is just key in everything that needed and run it. It will come up with the output also, W stages, a graph, and plus two things, which is condenser and reboiler duty. So it just basically like that. But I believe the things that you need mostly is only on the McCabe Thiele method, which is on calculate D, W, and all those stages and fit locations. So that's all from me. So if you need this coding from me or you have any questions, you can always approach me. Some of your friends might know me, and you can get my contact number from them or any contact way from them. So thank you for watching. Bye bye.